Okay, so the question on the table is, for lesson 8-1, for each figure, describe the base, name the figure, and name PQ. Okay, so the very first one that we're going to be looking at, and I'll do something similar. I'm not going to do that exact one because I think that then you're just trying to get answers out of me. All right, so what I'm going to do, okay, well, what's the odd one then? What kind of shape is it? It's a square pyramid. All right, so 8-1 continued. All right, a square pyramid. Got it. I'm just saying it how I heard it. It's not quite what I'm looking for. That's a little better. Let's say that's a square, but it's slanted. Okay. And let's say that we're going to say that it has 4 right angles so that we know it's a square. I'm just saying it how I heard it. Oh. 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 Okay, you know what? No. No. All right. Ha ha ha. A square pyramid. All right. So, there we go. Oh, no. Okay, so here's my pyramid. All right, and the first thing I'm going to do this morning is I'm going to look at, hey, I'm going to look at PQ. Now, where is PQ on this one?
Yes, it is. It's the top vertex to one of the sides.
So, this distance here?
Correct.
What's the top point called?
In the book, it's upside down.
That's fine if it's upside down. It's called Q at the top, so it would be the point. And P is this point right here. Okay, that's a great question that he asked. All right, first thing you have to understand about figures is that they have different pieces, okay? And we didn't really talk about this as much. We were talking more about types of shapes and how to draw them. So let's say that we are working with, okay, let's say we are working with that face of the pyramid. Anytime you're working with anytime you're working with, I'm having a heck of a time here. Anytime you're working with a particular solid, you'll have a base. Okay, the base is usually, for a pyramid, it's always the bottom. So we're going to call this the base. On a prism, you have 2 bases. On a cylinder, your bases are always what? The circles. Okay. But then you also have other components of your solid that you have to deal with. Okay. One of them would be this red shaded region. All right, and that is called a lateral face. More specifically, a face. This pyramid has how many faces? The base is also included in this. Yes. 5. Very good. 4 that go up to the point, and the base counts as 1. So it's got 5 faces. You think of it if you have dice. Anyone ever played with dice before? You rotate dice. A dice has 6 faces. Okay, and every one of those faces has a different number of dots on it. Okay, but that's not it. There's also edges. Anywhere 2 faces meet is called an edge. Okay, so I'm going to go ahead and, so this here and there and there, these are all edges. Okay? And there are more edges. There are lots of edges in a pyramid. As a matter of fact, there are 1, 2, 3, 4, 5, 6, 7, 8 edges in this pyramid. Yes?
Well, I was looking at something like something would
Well, hang on 1 second, and when I'm done with this, we'll look at it. So if this was our image, and we have a base, lateral faces, and edges, PQ would be what? A face, a base, or an edge? Yep, PQ in this particular case is an edge. So we would say this is edge PQ. Edges are where two faces meet. You can think of it as like a corner of a desk, the edge of a desk. Now, let me draw a cube. Okay, this cube has a face right here. It also has a face right here. It has a face here. Okay, so this cube has several different faces. As a matter of fact, it has 6, like the dice. But it also has edges. This is an edge. That's an edge. That's an edge. This right here is an edge. There's an edge. There's an edge. There's an edge behind the scenes there. There's an edge behind the scenes there. There's an edge right there behind the scenes. There's an edge right here, which is kind of blatant. There's an edge here, which I have not named yet. Okay, so there's several edges, if you haven't noticed, on a cube. Hey, no way. Really? 1, 2. Hey, don't, no, right in the front. Look at that. Edge right here. Are there that many arrows? Is that how many arrows? There are 12. There are 12 edges. Count the arrows. So a cube has a few edges. Okay? It also has corners where multiple faces meet. It could be a vertex if you're measuring an angle. But if we're just saying where multiple edges meet, we could call that a corner. Corner is where 3 or more edges, usually in this case 3 edges meet. So there's a corner here and here and here. Corners are always points. Edges are always line segments. Faces are always planes. Let me write that down because I think that's important. Okay? Corners are always points. Edges are always segments. And I'll put the other one above it. Faces are planes. Planes, points, and segments. Faces, corners, and edges. Okay, planes, points, and segments. So you're really just trying to identify the geometric version of something you're probably already familiar with. All right, let's take a look at another problem here. Emma, which one? Skew. I know. Hang on. Thank you for bringing it to my attention. Let's go back to the Math 7 notes. This is not Math 7, but we did a really nice drawing in Math 7 class of skew lines, so I'm going to take you there to show them to you. Okay, so let me bring this up on the screen. All right. So here's something we were talking about in Math 7. Perpendicular lines, parallel lines, different types of figures, angles, etc. Here are 2 planes, okay? Plane G and plane Y. And what we're doing is we were looking at how different lines work, okay? So if you look closely here, I have perpendicular lines on plane G there. I have a line in plane G there. I have parallel lines in plane Y there. Grace, would you please answer the phone? I also have a line that goes through both planes right there. Okay, and I'm on my way. Okay. And, okay. Take a look and see if you can find the, Okay. See if you can find the skew lines. They're not, oh. No. So we've got skew lines are lines that do not intersect, that are not parallel, that are not perpendicular. Okay? What ones would be skew here? Okay? You're going to have to be very descriptive because they're not labeled. Chloe. Okay? But I will say, okay, so, but you always, skew lines is plural, so you have to have two lines. Those would be parallel because they're both, look at my highlighted lines. They're right next to each other. So we can't say those are skew. Remember, they cannot be parallel in any dimension. They cannot be perpendicular in any dimension. They can never intersect. They basically are two lines that would never intersect in any dimension anywhere. Okay? Colby.
The line on plane G and then one of the parallel lines on plane Y.
Perfect. That's exactly what I intended.
How can they not intersect?
They will never intersect. Hang on. That's exactly the point. That's why we call them skew. Yeah, you just identified it. Nice job. They will not. These planes never, ever, 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 ever touch. This line is in that plane. That line is in that plane. They will never, ever, ever, ever touch.
But why is that one line going through both of them?
But these are not part of what I'm talking about. It's this one and this one. Imagine you have a dice. Okay, you have dice, and you draw a line on the top of the dice, and you draw a line on the bottom of the dice. Those lines will never, ever meet.
But they're parallel.
Not necessarily. One could be going like this, and one could be going like this. This line will go infinitely in this direction. This line will go infinitely in this direction. They don't intersect. They're not parallel. They will never, ever, ever, ever meet. Ever. Okay? That's what skew lines are. Skew lines will never, ever, ever, ever meet, and they have no relationship to one another. They're not parallel. They do not intersect at all. So if I have, let's imagine the lines on these boards are lines. These will never, ever intersect. These lines will infinitely go in this direction. These lines will infinitely go in this direction. They're not parallel. If they were parallel, they'd be like this. Okay? They're not perpendicular, or they'd be like that. Okay? They'll never intersect, or they'd have to be like that. These will never, ever, ever, ever meet. Yes?
But how would you identify a skew line in real life besides having the plane? I mean, if you just drop that, that'll fall and then they'll intersect.
No, they won't. Because this is just an example. There are planes everywhere. The ceiling and the floor. The ceiling and the floor are two planes architects look at. They look at how different lines will never, ever meet. It's important when you're reading architectural plans that edge up there never meets that edge, or your room will definitely be weird. Okay? It's important that they look at those kinds of things. That top corner of the classroom is skew to the bottom corner of this classroom over here. This window, this edge right here of this window is skew to the block line over here on the wall. They will never meet. They're not parallel. They're not perpendicular. Okay? There's skew lines in this entire room. Architects use them all the time. Yeah.
So like, I was just thinking about this. Construction is basically like a ton of geometry and then work.
Yeah. That's it. An architect's somebody who's skilled in the art of geometry. Someone who can take geometric shapes and manipulate them to make unique figures. Like in SketchUp. So this right here, ladies and gentlemen, this right here, these are skew lines. They never meet. They're not parallel. They're not perpendicular in any dimension at any point in time. Those are skew lines. No, not necessarily, but you could. If you drew an example of skew lines, that's good. What's hard to understand is you have to look at this in 3 dimensions. This line right here is not going up and down. If it was going up and down, it would have a dotted version going through the planes. This is on the plane going infinitely in all directions, in this direction right here. This bottom one is infinitely in this direction. They will not intersect. Okay? They will never be parallel. If they were parallel, this one up here would have to be going this way. It'd have to be like that. Okay. Any questions? Okay. Let's go ahead and give you your homework then.